First, we will look at the constant function. The limit of a constant function at any point C will be the constant value of the function. Here is the graph to make it clear. And we can also use the notation limit of k as x approaches C equals k. Now have a look at the identity function. The limit of the identity function at any point C will be C. As you see the function, at point C the function value will be C and the limit will be also C at this point. The notation is the limit of x as x approaches C equals C. Now that we know the limits of the identity function and the constant function, we can have a look at the properties of limits. The sum property means that the limit of a sum equals to the sum of the limits. Similarly, the difference property, the limit of a difference is equal to the difference of the limits, and the product property, the limit of a product is equal to the product of the limits. The scalar multiple property means that the limit of a function that is multiplied by a scalar is equal to the scalar times the limit of the function. Quotient property means that the limit of a quotient is equal to the quotient of the limits if the limit of the denominator is not equal to 0. The power property means that the limit of the function's nth power is equal to the nth power of the limit of the function. And the nth root property means that the limit of the nth root of a function is equal to the nth root of the limit of the function. Of course, it is only true if the limit of the function is greater than 0 when n is even. I hope that you also noticed that x approaches the same value on both sides of the properties. In the first example, we will use the properties of limits to evaluate each of the following limits. In the first question, we have a quadratic function and we need to find the limit as x approaches 4. As you see, we can use the difference property first, then the sum property. So therefore, our first term will be limit of x squared minus limit of 6x plus the limit of 3. As you see, the first term has a power function inside, so therefore we can use the power property, which will give us the limit of x to the power of 2. Here we can use the scalar multiple property, which will give us minus 6 times limit x, and then we don't change anything in the final term, so plus limit of 3. I hope you remember how to find the limit of the identity function. Well, at any point, the limit of the identity function is equal to c. So therefore, since x approaches 4, the whole value of this limit will be 4. So this first term will be 4 to the power of 2. The next one is the very same limit, so it will be also 4. So minus 6 times 4. The last one is the limit of a constant function. I hope you also remember that. The limit of a constant function at any point will be equal to the value of the constant. So therefore it will be 3 plus 3. Now we need to summarize all this and it will be negative 5. In the second question, we have a limit of a quotient. This means we can use the quotient property first, then in the numerator we will use the sum property, in the denominator we will use the difference property. Then we will simply use the scalar multiple property, then the power property. So here we go, this is what we will get. As I said, first we will use the quotient property, so we will have limit of the numerator over limit of the denominator. Then we can use the sum property, the difference property, the scalar multiple property, the power property, and now we have very simple limits to find. The limit of x at -2 is equal to -2, so therefore this first term in the numerator will be 4 times -2 to the power of 3. This will be the limit of a constant, which will be equal to the value of the constant, which is +1. Here again the limit of the identity function at -2, which is equal to -2, and then minus the limit of a constant again, which is the same value as the constant value, which will be 5. Now we need to find the value of this fraction, which will be 31/7. And the last one, the limit of a radical function. So first of all, we can use the root property, which will give us the square root of the limit of the function. Now we can simply use the difference property, so we will have square root the limit of 8 minus the limit of x. We know that the limit of the constant is the value of the constant, so this will be 8, and the limit of the identity function at a point will be the value of that point, which is 3. So it will be square root 8 minus 3, which is square root 5. Now this is your turn to practice. Please pause the video and press continue once your answers are ready. And the answers are: you may have noticed that whenever we wanted to find the limit of a polynomial function, the limit at point C was the same value as the function value at point C. Similarly, with rational functions, if I consider this rational function Rx equals Px over Qx, then the limit of the function at point C will be equal to the value of the function at point C. But we have to be careful because QC cannot be equal to 0. The denominator of the function at point C cannot be 0. We call this method direct substitution. We will see how it works in the next slides. In these two examples, we will use direct substitution to evaluate the limit. It means that we will substitute the point C into the place of x. So this time we will substitute 3 into x. So we will get 2 times 3 to the power of 3 minus 6 over 3 minus 3 squared. If we evaluate, we will get -8. This means that the limit of this rational function as x approaches 3 equals -8. Let's see another example. Let's try direct substitution. Well, if we substitute 1 into the place of x, we would get 0 over 0. We call this indeterminate form. This means that we cannot use direct substitution to find the limit. It doesn't mean that the limit doesn't exist. It only means we have to use a different method to find it. Let's see the graph. If we look at our graph, we can approach 1 from both sides, and we see that the function values will approach number 2 from both sides. I suggest you to pause the video now and try to find the following two limits using direct substitution. Let's see what happens. I hope you all received indeterminate form. So this means we would get 0 over 0. What are the strategies here? Well, we can try to simplify this fraction. If we factor the numerator, we will see that we can simplify this fraction, which will give us a much easier limit to find. Here, in this limit, we can easily use direct substitution, which will give us -4 minus 5 equals -9. In the second case, we would need to factor the denominator, and it's very easy. We need to use synthetic division, divide the denominator by the numerator, and see what we get. If we factor the denominator, we would get x squared minus 7 times x plus x minus 3. If we simplify with x minus 3, we would get a simpler limit, 1 over x squared minus 7. If we substitute here, we will not get indeterminate form anymore, so this will be our correct limit, 1 over 2. And one more question here. Again, you can pause the video and see what you get if you use direct substitution. Here, again, we would get indeterminate form, so we will need to use another trick to get a simpler fraction. Here we can rationalize the numerator. This means that we will have to multiply with a fraction that is equal to 1, but it's in a good form for us. We will have to use the conjugate of the numerator. This way, we will remove the radical expression and we will have a radical in the denominator. If we do so, we will be able to simplify by x minus 9. So we will get a simpler fraction, and if we use direct substitution here, we will get 1 over 6. And now it is your time to practice. As a start, you can always use direct substitution. If it doesn't give you a limit, or if you get indeterminate form, you need to use another way to find it. Here are the answers. Now we finished our first learning objective. Let's move on to the second one. Let's talk about the limits of power functions at infinity. The limit of any power function at positive infinity will be also positive infinity. As you see, as x approaches infinity, the function also approaches positive infinity. That means it is increasing with no bound. Similarly with the odd power function, as x approaches positive infinity, the function values also approach positive infinity, so will increase with no bound. Let's see what happens at negative infinity. If n is even, it will be positive infinity. As you see, with an even power function, as we decrease with x with no bound, our function still increases with no bound. But if we look at the odd power functions at negative infinity, this means our x will decrease with no bound. Our function will also decrease with no bound, so that means the limit of the power function at negative infinity will be negative infinity. Of course, if n is odd. Whenever we are talking about a polynomial function that has several terms, the limit at positive infinity of this whole polynomial function will be equal to the limit of the leading term of this polynomial function at infinity. Similarly, the limit of the polynomial function at negative infinity is equal to the limit of the leading term of this function at negative infinity. This means when we have a polynomial and we would like to observe the end behavior, it is enough to observe the leading term of the function. Let's see some examples for this. Let's evaluate the following limits. As I mentioned on the previous slide, whenever we have a polynomial, it is enough to find the limit of the highest degree term, because that will be the same limit as for the full polynomial. So therefore, in the next step, we can simply say that the limit of 4x to the power of 5 as x approaches negative infinity. Now we can use the scalar multiple property. So it will be 4 times the limit x to the power of 5 as x approaches negative infinity. And since x to the power of 5 is an odd power function, it means that the limit of this function is negative infinity. So 4 times negative infinity is of course negative infinity. Now let's see what to do in the second question. Again, we can use the same idea. We can use the highest degree term and find the limit of only this term. So the limit of this term is shown as limit of negative x to the power of 3 as x approaches infinity. Now we can again use the scalar multiple property, because a negative sign is like a -1 multiplier. So we can say that minus the limit of x to the power of 3 as x approaches infinity. As x approaches infinity, all power function will have a limit of infinity. Keeping this negative sign at the front, we will get negative infinity. Let's see the limits at infinity for rational functions. Now, if we look at the reciprocal function at positive or negative infinity, we can see it is 0 for both directions. So as x approaches negative infinity, my function value will approach number 0. Similarly, as x approaches positive infinity, the function value will get closer and closer to 0. For any positive integer n, the limit of 1 over x to the power of n at positive or negative infinity, it's both 0. And we can use this knowledge in the following questions. If I want to evaluate my first limit, I need to divide all the terms by x. If I divide both levels by x, I will not change the value of my fraction. So this means I need to write up this modification. I will simply simplify with x in these first terms, in both the numerator and the denominator. So I will get this. I will have simple reciprocal functions here. And now I'm going to use the properties of limits. Here we go, sum and difference property, and also the scalar multiple property for both of these reciprocal functions. Now, I know that the limit of a constant will be the constant value all the time. So for these two, I will have 4 and 8 for the limit. And here, the limit of the reciprocal function will be 0. So this is what I get. 4 plus 5 times 0 over 8 minus 3 times 0. These products are 0, so 4 over 8 is 1 over 2. Let's see what happens in this second question. We use a very similar method, but since here we have x squared, x, and x cubed, we will choose the highest degree term. So we will use x cubed and divide each of the terms by x cubed. So let's see. X, here we can simplify, we can simplify, we can simplify, and we have to leave it like this. So let's see what we get. 6 over x, 1 over x squared, 3, and 1 over x cubed. Now again, we will use the properties of the limits. Here we go. The scalar multiple property, and that was all. And then the sum and difference properties. Now we can evaluate each of the separate limits. Here, this will be 0, this will be also 0, this will be 3, and this will be 0. So therefore, it will be 0 over 3, which is 0. And now it is your time to practice. Please pause the video and press continue once you have your answers. And the answers are